Hello everyone. Here are some guided lecture notes for Chapter 1, which include basic terminology for the study of statistics. And in Section 1.1, it's an overview. First off, the definition for statistics. And be careful, we'll talk about a statistic in a moment. But statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. So it's a process where you would collect the data, and we'll see different ways to organize it, different ways to analyze it, and then we'll make interpretations based on the results. So the data is just information coming from observation counts, measurements, or responses. And if we're talking about a single piece of data, it's referred to as a datum. And we could either obtain the data from a population or a sample. And typically it's not feasible all the time to obtain the data from a population, so we often just rely on a sample to make inferences about the population. And the population is a collection of everything, all the outcomes, etc., as you could read there. And the sample is a subset of the population. So in an example here, we talk about a survey of 123,456 adults, and they were over the age of 45, and asked if they heard of Lady Gaga. And of those surveyed, 67% responded they have. So we want to identify the population. So the population would, in this case, would be all of the adults in the United States. And the sample is the 123,456 adults. And the data set basically consists of the responses of the 123,456, I guess we could say adults in the U.S., to be more precise. Adults in the U.S. To the question. I'll put the little ellipses, the three dots there. Okay, so then we get to definitions for what we call a parameter and a statistic. A parameter comes from a population, so it's a number that will describe the population. And a statistic comes from a sample. So be careful, in my math lab there's a question that talks about the definition of a statistic and statistics. So remember, statistics is the formal science, whereas when we say statistic, we mean the number that's describing the sample. Now, the easy way to remember parameter goes with population is because they both start with the letter P. And similarly, statistic goes with the sample, and it starts with the letter S. So just a little observation that makes it easy to remember. So a couple questions here. Decide if we've got a parameter or a statistic. So here we're taking the average salary of 35 out of 1,200 accountants at a particular firm, I suppose, or company. And so the 1,200 would be the population of these accountants at this company, so the 35 is a sample. In this second part, we're talking about the salaries of Major League Baseball players, and the total, you can see in it, what is that, it's billions of dollars, over $2 billion there, but that's from all of the Major League Baseball teams, so therefore that would be a statistic, or excuse me, a parameter. So it comes from a population. So a sample, we were asked to determine if it's a parameter or statistic. So first thing, consider it's a sample, then it's a statistic. And if it's a population, then it's a parameter. And I'll be using these little double arrows here. You could just read that as implies or then. It's a little shorthand, makes note-taking easier. Then we define descriptive and inferential statistics. Descriptive statistics is the branch where we basically go through the process of the organization, summation, and display of the data. And inferential involves making inferences from a sample to generalize to a population. So, as I mentioned earlier, it's not often that we are able to obtain data from the entire population, so therefore we take the data from a sample and infer from that how the population will behave. So this question says, which part of the survey described in example 1 represents the descriptive branch, and then make an inference based on the results. So the descriptive is the 67% of the 123,456 adults. We'll just put the ... So that's the descriptive statistics. So we gathered the data, summarized it, and the inferential branch, if we want to make an inference about this, we could say the majority, I don't want to say 2/3, you could, I suppose, but let me be a little safer and say the majority. Now I'm generalizing to the population, so the majority of adults in the United States have heard of Lady Gaga. Okay, so continuing, we move to the next page where section 1.2, how we classify data. We classify it in two ways, either qualitative or quantitative data. And qualitative data are basically just, as mentioned here, labels, attributes, non-numerical. Whereas quantitative, think of quantity, of course, that's when we think of numerical entries, measurements or counts. But we have to be a little bit careful, as we'll see through the examples we have. The first one's pretty easy. The cities would be qualitative because they're just names, basically. And their populations are quantitative because they're counts or measurements. But then here's where we have to be careful. The daily high temperatures. Okay, that's definitely numerical, and that's a measurement. So quantitative. But although in part B, the player numbers for a hockey team, so we're talking about the numbers on their jerseys, although they are numerical in nature, they do not represent measurements or counts. They're just labels. And so therefore they would be qualitative because they're just labeling. You know, number 11 is this particular hockey player. And that's his label. Can't really do anything with it. It's not a measurement. Number 99 is not always better than number 11. Okay, then we get to levels of measurement. So we have nominal and ordinal. With nominal, I guess the key is you cannot make mathematical computations. Nominal meaning names, basically. It's qualitative only. Names, labels, or qualities. Ordinal can be either qualitative or quantitative, but you can range in order or rank them. But one thing about them is that differences between the data entries don't mean anything. So for example, in the AP top 5 football teams here, Associated Press, that's what AP stands for, this would be data at it's qualitative data, because they're just names of football teams, but they're ranked. They can be ranked. So therefore they would be at the ordinal level. As opposed to this set where, although you could rank them, they're not ranked. They're obviously qualitative, again, because they're just names. But they're nominal, because they're not being ranked or put in any particular order. And then we have interval and ratio. The key here being that with interval data, a zero entry is not an inherent zero. This would be like temperatures, for example. You could have temperatures that are above or below zero. So that's interval. As opposed to a ratio where a zero entry is an inherent zero. For example, snowfall. So you could either have zero, you can't have a negative amount of snowfall. Okay, then we move on to section 1.3 and talk about experimental design. You could read the 4 methods of data collection: simulation, survey, observational, and experimental. I'll just jump to the examples. And the first question is deciding which method we would use to collect the data for this study. So a study of the effect of a product's warning label to determine whether consumers still buy the product. Well, it's not a simulation because we're not creating a little process to determine the results. We're not asking anybody questions, so it's not a survey, but it would be an observational study. because we're not changing anything, we're just observing. Now, a study of how fast a virus would spread in a rural area, definitely we want this to be a simulation. Certainly not going to try to spread a virus. And then we get to a census or a sampling. The census is for the entire population. We've all filled out census forms if you're head of a household. And a sampling is just part of the population. So census entire, sampling part. And some of the sampling techniques that we use, you can read these formally, and we'll just go over the examples on the next page. So you could read through that. And we'll explain through example. So we got 250 rural and 250 urban people that were 65 or older, asked about their health, experiences with prescription drugs. So we're taking two separate strata. So this is stratified. Because we're taking two subsets, both with the same characteristics, and choosing samples from each subset. Okay, part B, for quality assurance, every 20th part is chosen. That would be systematic. We're basically just labeling. The parts and picking every 20th one in a systematic way. After a hurricane, divide a disaster area into 200 grid and choose 30 of them. So notice, let me flash the definitions again to show the difference between stratified, where we had two or more subsets called strata, and we picked a subset of each. So that was the first example. But now we're looking at cluster. We're dividing it into 300 pieces, basically, and selecting some of the clusters. So therefore, this would be cluster sampling. This is convenience sampling, so because we're just asking these college students. Probably get different responses if you ask the professors that were leaving about their drinking habits. And then finally a simple random sample. And finally we get to biased questions. So we consider it biased if it's persuading us in some way. For example, why is eating peanuts good for you? Well, that's suggesting that peanuts are good for you. So therefore, it's biased. And how could we rewrite that so it's not biased? Maybe just saying something as simple as, is eating peanuts good for you? So not persuading anybody in any particular direction. And so finally we get to what I would call an unbiased question, because it's not persuading you, talking about they had bad dieting habits or good dieting habits, just do you think the media has an effect? So that's not persuasive in any way, so it's unbiased. Alright, so that's the end of chapter 1. Relatively easy chapter, just terminology. And in chapter 2, the fun begins with more computational type things. So we'll see you when you're ready for section 2.1.